All right, so I just found this problem online, and the first thing I want to talk about is this concept of the word equal, okay? And when we use the word equal, we want to say that two things are the same. So what we're trying to do is take whatever is in this, grocery basket, and make sure that there is an equal number of pieces of fruit here and here. So what I notice is that I have two bananas and three oranges. Now, one way that I could do that is actually split these up so that I have an equal number of pieces of fruit over here. So that means that I would take away one of these bananas and put one of my bananas here, okay? And then I would take away one of these pieces of fruits, put it here, okay? And then I would take half of one of these pieces of fruits and put that half here, okay? Then I would have an equal number, all right? I would have one banana, I would have 1.5 oranges, and I would have 1.5 oranges as well. Now, that's just one way to do this. Let's look at another way. Now, the other way that I'm thinking about doing this is simply saying, okay, if I have three oranges here and two bananas in this basket, then I simply just need to add two bananas here and 1, 2, 3 oranges as well, and then they would be the same. The goal is that you have a left side of your equal sign and a right side, and you want to make sure that the left side is the same as the right side. And I know this doesn't look great, but that's the idea. Now, I know that a lot of people struggle with this concept of Common Core math, but let's look at what its ideals mean and represent. Now, this is a problem that I've been doing in my high school classes just to show them something. Now, if you were to subtract 29 from 71, you would probably do it the way that you initially learned it, okay? And speaking in terms of like a first and second grader, taking, just subtracting down your ones digit, like 1 minus 9, like they can't do that, all right? So what they've learned to do is they've learned to borrow from the 7, borrow 1 from the 7, put the 1 here, and then write 1 less here as 6. Now the problem states that you do 11 minus 9, which is 2, and then you do 6 minus 2, which is 4, okay? And you can obviously go, all right, well, 42 plus 29, does that give you 71? 2 plus 9 is 11, so you put the 1, carry the 1, and then you get 5 plus 2, which is 71. All right, and so that works, okay? And that's what we've learned for a long time. But the question is like, what does this mean by borrowing? Like, what are you exactly doing here? And I think that a lot of people struggle with that. And so here's how I have taught this, how to do this problem and how to think about it, all right? So if I take 71 minus 29, what I'm really doing is I'm taking 70 plus 1 minus 20 minus 9, okay? And this is what I do in my head. I struggle with mental math. I've been a teacher for, over a decade now, and I still just strive to perform better when I have to do mental math. So, one of the things is we encounter that same problem. 1 minus 9, we can't do that, right? So what we want to do is think about, well, what can we do to this 70 to split this up to give me more values in this 1 so that we could then subtract these two numbers. So what you do is you borrow 10 from 70, all right? And you rewrite this as 60 plus 10 plus 1 minus 20 minus 9. Now you can add the 10 and 1 to get 11. So you have 60 plus 11 minus 20 minus 9. Now you can do 11 minus 9, which gives you 2. And you can do 60 minus 20, which gives you 40. And you do 40 plus 2, and that's going to give you 42. And that's your answer. Now, you're probably sitting there and you're like, why do I need to do all this when I can just do this? Well, in reality, this is a shortcut, okay? And your level of understanding of how the numbers work and why you borrow a 1 from the 7 and you put a 1 here and get the 6. And a lot of it's on how you say it, but really this is the structure. And when you have a kid who's 7 or 8 years old and they can break this stuff down and they can reorganize it and they can then add those numbers that way, that's something that's really powerful, because at that point, they're learning the structure of mathematics and why, when you take 71 minus 29, why you get 42. Now, I can do this problem a bunch of different ways, but I'm simply showing you that this is what Common Core is, okay? This is a shortcut. Sure, absolutely, I'm all for this, and this is quick and easy, and it's way less steps, it's way less writing, but there's no thought process involved. This is simply a procedure where when you're over here, you're talking more about a concept about how these numbers work, okay? So, please embrace the concept of Common Core, because it's just challenging students to think. Now, again, I can do this a bunch of different ways, and I look at it the same way as this problem. I did this problem 2 different ways that make these statements true. That's the idea. What is equal or 2 things are the same. So, I love problems like this because I love talking about this, because I think the public just doesn't understand that what we're trying to do as educators is to provide structure and meaning to this mathematics, okay? And it may not be the easiest problem, and the answers may not be transparent, and I don't even know what the answer is. But what I do know is that I have true statements here and true statements here, all right? And so if I were a teacher of this class, if a kid gave me either one of these answers, I'd count it right and call it good. So hope you enjoyed this video, and we'll see you soon. Thanks, bye.